So the second application of integrals we're gonna discuss is associated with investment and capital formation. Okay, let's first remind ourselves a couple of things from your macroeconomics class. Now, what is capital? Remember, in common tongue, capital usually means money. But when economists, especially macroeconomists, talks about capital, what the economists think is the machinery, it's all the equipment that companies use to produce goods and services. Okay, now how do capital comes about? Where does it come from? Well, it comes from investment. Because investment, in macroeconomic sense, again, are the purchases of new capital goods by companies. Oh, those are private investments. Of course, we can have also public investments, but this is not the key thing for us at this moment. So we're going to focus on private investments only. Okay, so K, as usual in all your classes, denotes capital. Alright, but now I'm going to do in this case something that you probably might not have seen. I'm going to put a dot over K. Look, generally, from this moment on, every time when you see a variable with a dot over it, by definition, it will denote derivative of this variable with respect to time. So every time when when a dot is here, it's implied we taking this variable and we differentiate it with respect to time. So look, if I'm getting capital and I'm differentiating it with respect to time, I'm getting an information. This information is telling me by how much level of capital in the economy, because we are talking about macro now, has changed. But look, we just said the changes in capital come from investment. So in other words, we could say that by definition, dk dt is simply investment. But it's not any kind of investment. This is net investment. Okay, so look, by net investment, we mean by how much actually level of capital has changed in the economy. What is the difference between net and gross investment? We'll go back to this in a couple minutes, but for now, let's just remember that net investment is showing us what is actually happening in the economy. So, by how much capital in our economy has grown, or by how much has it fallen? Okay, so look, from this we can get that capital as the function of time must be an integral of investment over time. Okay, look, it makes perfect sense, because if I differentiate capital and I'm getting investment, look, if I'm going to be saying investment, I mean net investment. If I want to say gross investment, I'm just going to say gross investment. Okay, so of course we clearly see that if investment is a first derivative of capital, then capital must be an integral of investment. And look, we can easily show it. Look, Investment is by definition dk dt dt. Right? I just substitute. But look, those two cancel each other out. And I'm getting this weird expression, integral dk. Well, if you, at the beginning it might look strange, but if you think about it, if there's nothing in here, it means then we've got 1, right? So, if I'm integrating 1 with respect to k, I'm just getting k, of course, plus c. And because in our case, of course, k is a function of time, as you see, all of this is combining very nicely together. Okay, so maybe now let's discuss what is the difference between gross capital and net capital. Because look, I'm sorry, gross investment and net investment. Why do we need to make distinction? Well, because if we purchase some capital goods, they are not lasting forever. Even buildings need to be renovated from time to time to maintain still standing, right? You probably remember that, and I hope you remember that from your macroeconomics class, that the distinction between net and gross investment comes from depreciation. And look, let's say that by IG we will denote gross investment. Okay, so what are gross investments? Gross investments are all, of course we still talk about private sector, only to simplify, they're all investments, all the purchases of capital goods made by companies in a given economy. So, look, if company is purchasing new capital goods, is purchasing some capital goods, then it can be used in 2 ways. Look, for example, let's just say that the company what company is doing, if the company has trucks, and this company rents those trucks to other companies. And look, let's just say that within this year, 2 of these trucks have been really broken down. They need to have a lot of their parts changed. So what a company can do is to buy the new parts, install them in the trucks, and because of that, those trucks can be considered like almost new. You can say that they replaced everything that was broken, and because of that, the value of these trucks is more or less the same as it was 1 year before. Then, so in this case, company uses its resources, financial resources, to rebuild what was gone due to normal usage. Okay, so this is the first possibility. But what this company can do is that they can buy, for example, 5 new trucks. And this investment will increase the level of capital in this company from 10 trucks to 15 trucks. But look, what this company actually has done is purchased 5 new trucks and parts for 2 old trucks. Okay, so we see the gross investment, so the total investment, can be divided in two parts. First part is net investment. So you can say that those are the new trucks we are buying. But in the process, of course, of usage, we know that two trucks have broken down really much, so we needed to replace some parts. And in general, we will call these types of investments, so this expression as a total, we will call replacement investment. Okay, but what do we have inside this expression? Look, we've got lowercase delta and k. Okay, let's start. K, of course, we know it's capital. So this is the capital the company had at the very beginning. On the other hand, the second expression that you see over here, the lowercase delta is called rate of depreciation. So look, it's rate because look, our delta from here must be something between 0 and 1. Well, technically, if we would have some capital that would never go broken, then delta would be 0. And if we would have some form of capital that actually is completely gone after 1 year of usage, delta would be 1. But of course, those two corner solutions very unrealistic, so disregard them. And okay, usually the more or less good estimate of this delta is 10%. We can estimate, well, it differs from sector to sector of the economy, but overall we can say that due to normal usage, like 10% of the capital in the economy is gone. Okay, so look, what is this expression telling us? Look, replacement investment is telling us how much capital in the economy has depreciated. So it's like been destroyed due to normal usage. Okay, look, in our previous example, with trucks, we had 10 trucks, 2 trucks are broken. What is delta in our hypothetical example? Well, it's 20%, right? Because not exactly. Like, okay, if those 2 trucks were completely destroyed, that would be 20%, right? But so let's just say as we said, it's 10% because let's just say that due to the fact that the 2 trucks actually, have been not completely but destroyed in 50% each, we would get that 10% of the capital in this company would be gone. And look, what do we get when we think about this relationship? We can get a couple of very interesting facts. First, look, what if net investment is exactly 0? Look, then gross investment is equal to replacement investment. this is a situation that our company just decided to fix the trucks, and because they fixed the trucks, they still have 10 trucks. So look, even though gross investment is positive, but we just replaced some of the capital, we can see that net investment is 0. Why? Well, because we didn't get anything above the number of trucks we already had. Okay. Now, what else can we see? Now, can net investment can gross investment be negative? Well, no, it cannot be, because look, a gross investment can be 0 at most if our capital would not depreciate at all, and we would not buy anything new, then gross investment would be 0, right? Or even if the capital would depreciate it, but we would decide we're not going to fix it, then the gross investment it would be at 0. But the net investment, on the other hand, can be negative, because look, if net investment or just investment is IG minus K, right? Look, gross investment is all the money we are spending on different capital goods, right? So if we do not spend it, it can be 0 at most. Well, technically, we can imagine a situation when a company is actually destroying its own capital for some reason, but this is not rational, so we will abstain from this. Okay, but now look, here we see that if the amount of money that the company spends on replacement investment on all investment is actually lower than replacement investment. It's like, imagine that the company decided to fix just one truck. So our net investment is negative, right? Because the capital we've got in the company depreciated, and we didn't use enough resources to rebuild it to its state from before. Okay, so now that we've discussed this basically to death, let's just do one simple example. We will do more exercises on the vocabulary, so let me just give you. Okay, so our investment function, let's just say, is equal to 3 times square root of t. Okay, knowing this, how can we obtain the level of capital in a given economy? Okay, so we got that KT. So what we're looking for, of course, is an integral of investment with respect to time. So we get that this is integral of 3t to the power 1 over 2 dt. Okay, now if we integrate this, we will get that this is to the power 3 over 2 divided by 3 over 2 is like multiplied by 2 over 3. So we will get that this is 2t to the power 3 over 2. And, of course, plus c. Now, can I definitize this constant without any prior knowledge? Well, I actually can. And this can be done quite easily. I don't know how much capital was at the beginning, but I can definitely say that it was some K0. That was the initial level of capital before we started integrating. But look, this is bringing us to another point. Maybe a better way of dealing with this problem would be if we use definite integrals, because with definite integrals we will be able to actually track evolution of investment and then capital over some period of time. And look, this is also very straightforward. If I want to, I have some 2 time points. Let's just say one is A, second is B. Then if I integrate investment, I will get, of course, capital. And of course here we will have A and B. And to obtain by how much has the level of capital in this economy grown from point A to point B, those two being points in time, we get that this is given by KB minus KA. Okay, so this answer, this notion, it can be understood very, very nicely once we put all of this in on the graph. Okay, so let me just erase the blackboard, and we will use 2 graphs. Okay, in the first graph, we will have net investment. Look, I'm going to be abstaining from negative investment. I will assume that as it's usually the case, that level of investment in the economy, net investment, is positive. So, on this axis we have time, and look, on this axis I have level of investment in the economy. Doesn't really matter for us how much is it. We see that sometimes it's bigger, sometimes it's lower. This is probably associated with some business cycle, but we're not going to get into business cycles in this class. Actually we will, but a little bit later. Okay. So then on this graph, what I wanted to draw is capital. And look, here we see that each year investment was positive. This means that capital, actually we start from some K0, the capital has been growing. Sometimes faster, sometimes slower, but it's been increasing. Okay, so now let's see. If I want to see, like, I'm interested in how much capital was formated, accumulated from time t0 to to some time t1. How would I do it? Look, I would do this. I would calculate a definite integral from some point of time t0 to some point in time t1. What would I get as a result? Well, as a result, I would get this area. Okay, and let's say that the size of this area is x. Okay, now, what if I want to do the same on this graph, right? What can I do? Look, I can also put those 2 points, some t0 and some point c1. And now, where can I find my solution? Well, very common mistakes among students is to look at over here. Of course, look, remember, when we get from investment function to capital function, it means that this function is already an integral, that this function is an integral of this one. So those areas that we are calculating below should be corresponding to the values of this function over here. So look, if level of the capital in this economy at time t0 was so k t0, and at time t1 it was k t1, by how much level of capital has increased? Well, by kt1 minus kt0. So look, if I would measure the size of this line over here, it would turn out that the size of this line, length of this line, is equal to x. Look, of course, I know that it might be strange at the beginning when you think about it, but look, this is an area, and the size of this area is x. Here we just have one line, but look, this function represents integrals, it represents an integral of this function. So the areas we would be obtaining over here would be equal to the distances we obtain over here. So as you see, the accumulation of capital you can see either as the area below the investment function, net investment of course, or you can see it as the distance between the 2 points on the capital function graph. Okay, again, let's illustrate this with a very simple example. Actually, let's use the same one. But now, let's just say that investment function, okay, is still equal to 3 times square root of t. But this time, we are interested in how much capital was accumulated before, from, let's just say, the 1st to the 4th year. Okay, so, how do we calculate it? Look, again, all we gotta do is to calculate definite integral. This time from 1 to 4 out of 3t to the power 1 over 2 dt. Okay, we already found indefinite integral, right, over here. So we know that this is 2t to the power 3 over 2, 1, 4. is to just substitute the values. So we got that this is 2 times 4 to the power 3 over 2 minus 2t, 2 times 1 to the power 3 over 2. And look, 4 to the power 3 over 2 is 2 to the power of 3, which is 8 times 2 is 16. And of course, 1 to any imaginable power is 1 times 2, it's 2. So we got that over the period of 3 years, we've accumulated 14 units of capital. Okay, look, let me just show you one more identity that is going to be very important to us in the future. Okay, and this identity, again, we can use as a generalization of what we seduce for. Look, if I'm going to integrate investment from some point 0, so from the beginning until some moment, in the future at time t, well, what I'm going to get is the capital function. And now, look, if I'm going to substitute those two, I'm getting that this is kt minus k0. Okay, now if I'm going to use only those two, we get that this integral is of course equal to kt minus k0. Now, if I'm going to rearrange the order of the expressions over here, we will get that level of capital at time t is equal to level of capital at the very beginning plus the capital formation from year 0 till year t. And this formula gives us the final connection between investment and investment capital formation and the level of capital, right? We had at the beginning, we had some level of capital in the economy, then this level, then through investment, this level has been rising. This is measured through this integral. If I'm going to add those two together, then kt is going to, then I'm going to find the capital function. Okay, so thank you for your attention. In the next video, we're going to start analyzing third application of integrals. We're going to discuss third application of integrals in economics, and this is going to be associated with calculating the present value of cash flows. Okay, see you in the next video.